Welcome. We're going to discuss these two theorems again with different examples. So here we have a moment generating function given by e to the lambda times e to the t minus 1. If we go up to our list of distributions, we see it matches a Poisson distribution. So we know that x is Poisson with parameter lambda. If we were asked to write down the density for a Poisson, we could look it up and see that it's e to the minus lambda times lambda to the x divided by x factorial. That's not listed there, just know the Poisson density function. So that is an example of the uniqueness theorem, that very first theorem. Now we're going to illustrate the second theorem, which you've seen before. It says if xi are random variables, and they also need to be independent, with moment generating function mxi of t, then the transformation given there corresponds to multiplying the moment generating functions as listed below. As an example, we have x1 and x2, which are IID Poisson random variables. Our goal is to determine the distribution of y, which is equal to x1 plus x2. Since we're told that xi are Poisson random variables, we can just write down their Poisson moment generating function as being e to the lambda times e to the t minus 1. So using the transformation theorem that's listed above here, we have that my of t is going to be mx1 of t times mx2 of t, and we just wrote down the moment generating function e to the lambda times e to the t minus 1 multiplied by e to the lambda e to the t minus 1, and this will be e to the 2 lambda times e to the t minus 1. Now, if I let mu equal 2 lambda, then this is the moment generating function of e to the mu times e to the t minus 1. This is a moment generating function we've seen before by the uniqueness theorem. This matches the moment generating function of a Poisson distribution. So that tells us that y is Poisson, and its parameter is 2 lambda, twice the mean. So the parameter of a Poisson is the average. The average of y is mu, which is twice the average of x1 and x2. And so we know the distribution and the density function of y. Thank you very much.